In this video, we're going to learn how to use the laser rangefinder. This is the rangefinder here, and what it does is it lets us measure the distance to objects, out to about 2 meters. And in the program here, which we've got running, we're displaying the readings from the sensor in millimeters. So as I move it away from the table, the distances increase, and I get closer and they decrease. And likewise, if I put it on its side, it will tell me how far away my hand is. And back again. And this is a really useful thing to have in a robot, especially if you want to avoid obstacles or measure distances to make a map, etc. So next, we're going to learn how to use the sensor. The main resource for this video is the Laser Rangefinder USI page on jb.works. Enter the TMT code at the right at the search prompt and you'll be taken straight to the page. From here, you can get example programs, commands, all about the laser rangefinder. For this guide, you will need a charged JackBord, 4 short female-female jumper wires, a laser rangefinder USI, an M4 nut, M4 bolt, and a spanner and an Allen key. Putting it together is pretty easy. The main thing to keep in mind is that the sensor uses a protocol called I2C, and on the JackBord that's on port D. So we're going to attach the sensor to port D, whereas most of the time we usually attach it to A or B. So it's putting the bolt in, get the nut, we'll just attach the sensor. Very simple. Again, don't do it up too tight. So the next thing we'll do is take a green wire and take it to the green ground pin on the sensor and over to the green ground pin on port D. The sensor needs 3 volts, so we're going to use a yellow jumper from the yellow pin on the sensor to the 3 volt pin on the JackBord. And next we have the 2 data lines. The first one is the actual serial data line, which is the white pin. And that goes from the white pin on the sensor over to port pin D5 on the JackBord, which also happens to be the SDA pin. And then the clock pin from the sensor is the blue pin, and that goes over to port pin D4 on the JackBord. So our connection should look like this. Here are some pictures you can use to check that your connections are okay. Compare yours with these and make sure that they match. And pay particular attention to the fact that the blue wire goes to the blue pin and the white wire goes to the white pin. You don't have to use exactly the same colors as I have, but it helps. Before we start using it, it would pay to know something of how it works. In the center you can see a very big version of the sensor. In the lower right hand side you can see the sensor full size as it appears on the JackBord USI. To the right of the center picture we have a transmitter, and that sends out a very weak laser pulse. And when it hits something, a portion of it is reflected back. And the receiver is on the left of the chip, and that's what detects the laser's reflection. If there's no object, there'll be no reflection. In this case, the reading from the sensor will be 8,000, which means that there is no reading or no object. It does this hundreds of times a second so that we can tell very accurately how far away something is from the JackBord. Now that we've got the sensor connected, we can use the command line to start getting some readings from it. So the commands are shown on the top right hand side of the screen. And the first one is the F2C command, and because the sensor is connected to the I2C bus on port D, this command tells the JackBord to find any I2C sensors. And so what it's going to do is find the distance sensor, which it has on channel 37. And then we can list the devices it's found by using the L2C command, which stands for list I2C devices. And you can see here that it's found our laser rangefinder, and that's excellent. And then finally we can go GT, and what GT does is it gets the current value. So right now we're at 39 millimeters. If I pick it up and move it a bit and then run GT again, I get 100 millimeters. And so basically you can see that we're getting different readings as we move the sensor. And if we go to the live page and we look at channel 37, you can see that that also changes as we move the sensor. Now that we've got the basics, let's have a look at some programs. Program number 1 is a simple program that just displays readings from the sensor. You can get the code for it by going to jb.works and enter the TMT code shown on the screen at the search prompt and press enter, and then just copy the code into the program page. Now this is program number 1 and we've placed it into the prog page. And I'll just go through it quickly. First of all, we've got a variable here called dis, which we actually don't use, but it's just there anyway. The next thing we do is we clear the screen and then we just print some information for the user. And this is the F2C command here, and this is the one that finds the sensor. Then essentially we just go into a loop and we use the s_ldist system variable. So when you first connect the laser rangefinder to the JackBord, Optigan automatically finds it and links it to this variable. So all the distance readings from the sensor will appear in this variable. And then we just wait a quarter of a second and keep on doing that. So if I run the program, there we go, it says it's finding it, and there it's showing the distance readings. So now if I lift it up, they get higher. If I go down, they get lower. And you might notice there's a bit of noise because right now it's just sitting there, it's not moving at all. And that's just inherent noise in the sensor. And it's due to all sorts of factors. Nothing is perfect. So this program is just getting the readings from the sensor and displaying them in millimeters as a text list. Program number 2 is a little bit more elaborate because it uses the show page to display the values. To get the code for that, again visit jb.works and type in this TMT code at the search prompt. Paste it into a free spot in your prog page and then we'll run it. This is program number 2. Now I just want to go back to the idea of system variables, and that's this s_ldist variable. The idea of a system variable is that it's automatic. You don't have to create it yourself. Optigan does that for you. And they're pretty useful, and you'll see more of them as you use the Optigan language. In the meantime, just looking at the program, it's basically the same as program 1, except we use the show page for its output instead of the print page. So the first line is we just print a title, then we add the quit button, and then we find the sensor same as before. And here we're using a put text line command to just display the text, display the distance in big letters. So if I run the program, we have laser rangefinder, and there are the distances. And again, if I lift it up and down, there we have the distances being displayed in real time. And then you can point it around different places and get different readings. And the sensor's good in theory out to 2 meters, but that will depend on how the environment is, like what surface it is you're reflecting. And if I point it somewhere where it's more than 2 meters, like up at the ceiling, when it goes to 8,000, that means that it's out of range. There's nothing it can see, it can't detect anything. But then if I point it straight at the camera, oh, you can actually see the laser. So if you look at the flashing on the sensor, that's the laser taking laser readings. We can't see it with our naked eye, but the camera can pick it up. And it's those pulses of laser light that are giving us the distance readings. Here's a summary. The sensor can measure out to about a distance of 2 meters, and it uses a low power laser, so it's safe. And we saw that when you looked at it with the camera, you could actually see it pulsing. To detect the laser in the beginning, you need to use the F2C command because the laser connects to the JackBord's I2C bus. Then you can use the GT command to see its values. And finally, there is a variable called /s_ldist, and this is an Opticon system variable and will always have the latest distance reading from the sensor. And finally, a reading of 8,000 means that the sensor couldn't detect anything. There were no objects within 2 meters. So basically it's out of range. For more information, visit jb.works.